So today we're going to be talking a little bit about the Artel PCS. My name is Nicholas Anea. I am an application scientist specifically located in the West Coast in the Bay Area, California. For those of you who don't know what the Bay Area is, think of San Francisco. That's where I'm currently located. So hopefully everyone's here for the right reason today, but that we're going to be talking a little bit about the PCS. Cool. So before we begin with the PCS, I just kind of wanted to go over Artel and what we have to offer as a whole. We are the standard when it comes to volumetric verification. I don't say that lightly. So the first product that we have that I'm going to illustrate, and we won't talk about this extensively, I just kind of want to let you guys know our menu and our offerings, is the Artel NVS. Think about this as more towards automated liquid handling or really, really large scale multi-channel pipettes. The NVS stands for multi-channel verification system. We also do automated liquid handling services in which our experts like myself will come out and will help you fine tune your liquid handlers with our NVS and get those specific results. We're also notorious for our pipette training courses where we actually go A through Z through all of pipetting, from learning about the pneumatics of pipetting to actually mitigating some operator discrepancies and also scaling up user training. And then lastly, why we're here today is for the Artel PCS. Cool. So the Artel PCS, this is what it looks like standalone. Kind of looks like a little bit like a rocket ship. It's a pretty small, compact, cool system. So the size of this, and for those of you that haven't seen it in person, it's probably the size of a shoebox. Now, I have size 13 shoes, so probably around that size of a shoebox. If you have like a size 6 or something like that, maybe a touch bigger than that at that point. So what comes with the PCS, right? So the package for the PCS comes with the PCS, and we'll kind of go through the intricacies of what the PCS has in it. It also comes with a laptop, which will run our software that ultimately controls the PCS. It comes with a label printer, so there's brother label printers to print out labels for your pipettes, whether that be the calibration label or an asset label for the pipette. That brother printer is already integrated. We have our QualAssure solutions, and we're going to get into this. So if I lose you right now, don't worry about it. We're going to get into what ultimately these solutions are. We have blank vials, and then also we have a cal kit. These QualAssure solutions come in packages. We have 2 flavors, a bulk and a standard kit, that comes with a different assortment and quantity of these QualAssure and blank solutions in general. So that's what the overall package looks like. Just kind of wanted to outline that for you while we're here. Cool. So like I promised you, we're going to get a little bit more into the nitty-gritty of what all of these are. So let's do that now. So one is the calibrator kit. If you look at this, this is a pretty granular image, but it has 4 varying degrees of our dye, from really nothing all the way to a highly concentrated version. These vials are spec'd in our reference ISO lab back in where we're located in Westbrook, Maine. So great thing about these kits is one gives you traceability, but it also lets us know that your system is working on a monthly basis. So when we install these systems, we program these monthly. You just come back, you put these in, we get the absorbance values. It takes less than 10 minutes, and you're good to go for a month after that. These get changed out on an annual basis. You just order a new cal kit at that point. And that also renews the subscription to our software. Next, we have blank vials. This is ultimately what you're pipetting your solutions into. You're going to get to see this a little bit later. But these blank vials, pretty robust. They come either max volume or max absorbance, and we're going to talk a little bit about that in a second. Great. Next, let's move on to our QualAssure solution. So we have 6 flavors of our QualAssure solutions with varying concentrations of our red dye solution. So the ultimate dynamic volume range that we can do is 0.1 microliters, or about 100 nanoliters, all the way up to 5,000 microliters. And dependent on what volume you're going to be checking, you use the requisite dye at that point, or the requisite QualAssure solution. So if I'm testing anything within this 200 to 5,000 microliter range, we'd be using QualAssure 1. So on all the way down to 0.1 microliters. Cool thing that you're going to see a little bit later when we're actually walking through the software, you don't need to remember any of this. The software knows exactly what volumes, and it will have you scan the requisite QualAssure solution to actually use it. So we went over a little bit of the cal kit, the blanks, The QualAssure solutions, we have about 6 of them with varying degrees of our dye. That's about it as far as the actual consumables go. So working volume, again, for everyone here, 0.1 to 5,000 microliters. So the dynamic range on this thing is pretty darn robust, especially when it comes to pipettes. Cool. So how does this thing work, right? Why are we here today? Now, we're going to talk a little bit about it, but the full principle of this is it's dual dye ratiometric photometry. Say that 5 times quick. No, I'm just joking with you. But this is an ISO recognized method. It's probably one of the most comprehensive, robust volumetric calculations out there. So in a nutshell, we're going to go over a little bit of how this works. If you really, really want the details, we can send you the white paper as well. But essentially, we talked a little bit about this before. You have your blank vials that have a trace amount of our blue dye in it already, dependent on what volume that you're going to be looking at with your pipette. So let's say it's 20 microliters. We'd be aspirating and dispensing 20 microliters into our blank vial. You can see that it homogenizes a little bit, but essentially with the PCS, it has an integrated vortex mixer to where vortex mixes the samples, and then it gets a reading. So I said 20 microliters in this example. Actually, they use 2 microliters. So we use absorbance at 520 and 730, so the absorbance of red and blue. And we'll get a little bit into this in these upcoming slides as well. So this is the whole principle on kind of the workflow of how the PCS works. Right. So like I talked a little bit with you guys, so we have our blank vial, which basically what we're measuring that is the initial absorbance reading at 730. So what will happen is the PCS will get that initial baseline absorbance, and we'll get that reading at 730 nanometers at that point. Then once we aspirate and dispense our sample in, essentially what we're doing is then we are calculating the difference in absorbance between 520 and 730. Then we use a lot of great math that I don't want to bore you with today, but we use a little bit of Beer-Lambert's law and a couple other principles to then get the most accurate calculations for your volumes at that point. But in a nutshell, this is how the technology works. Like I said, if you want to go variable by variable, we'd be more than happy to send you the white paper that kind of outlines in detail each variable. Cool. So you're going to see me do this in a little bit, but that's kind of the premise of how the whole system works. Great. I just kind of wanted to show you what it looks like in a lab. So this we put on a cart. Most of the time it's not on a cart. We just install it on a bench. The cart's an option, and we do offer that to you if you do want to get it separately, but it's very transportable. You can see what we were just talking about. We have an operator here dispensing one of our QualAssure solutions into the blank vial. She closes it and ultimately gets a reading. So it's really robust. It's very, very quick. We kind of just outlined what this video is going over. It's basically taking the difference in absorbance values between 730 and 520. So I just kind of wanted to show you what it looks like more so in a lab setting. So now let's talk a little bit about the software that ultimately runs this whole system. The software is very, very nice. And we've seen, just based on customer feedback, that it really increases lab productivity, compliance, and quality. The way that we design it is we can either support standalone structure or a client server infrastructures as well. It's SQL based, so pretty easy to integrate that as well. Great thing is it's A through Z when it comes to pipette calibration. So it really manages your inventory and your performance data, and you can pull everything up within a matter of seconds. We also have scheduling and notifications reminders in there. So if we network it, we have email notifications. So the owners of the pipettes will be notified on whatever cadence that they want to, whether that's weekly, monthly, quarterly, on what pipettes are due when they're due. And we also have part of the software that's an add-on, but compliance suite, which complies with 21 CFR Part 11. So the Audit Trail and the e-signature, that also we have integrated into our software. Cool. This is a great slide as well. We could go over all the different standards that we adhere to. The thing I like to tell all of our customers, we are basically like a regulator's kryptonite or an auditor's kryptonite. So we conform to ISO 8655, ISO 17025, all these other CGMP, CGLP. But in general, it's a pretty robust system, and most people buy the PCS besides the ease of use and the robustness of the technology for that regulatory compliance aspect of it in general. Part of this whole thing, right, like I was talking about earlier, we have the integrated into it, we have a digital review and approval workflow process. It's SQL database. And then I said earlier, the PCS supports 0.1 to 5 ml or 5,000 microliters. Anything over that, we could actually connect the software with a balance to read those readings out. So it's a pretty nice, robust system that's capable of doing a lot and with very little. Cool. So before I turn my camera over, I just want to check the chat to see if we have any questions at all. Boom, boom, boom. And it looks like, great. So it looks like I have a couple of people that answered. Ding, did you have a question? Go for it before we start.
Yes, I do. You said, you can connect with a balance if the volume is larger than 5 ml.
Mm-hmm.
And can the software connect it to the balance less than 5 ml?
Currently, no, we don't have that capability. Great question. Yes, it's only for volumes that are over 5,000 for the readouts within the software. And internally, we call it LVBA, which stands for, I think it's Large Volume Balance Assist as well. So yes, we don't have volumes that are lower than 5,000 that can be read within the software with the PC, with the software.
Okay, thank you.
Great question. Any other questions from anyone before I turn my camera over and we actually mess around with this? Cool. Megan, did you have a question too?
I did. So for so for the blank vials, so you can only use one per sample volume added. Is that correct? So if like you're doing a curve like 1 mil, 5 mil, you would only use one blank for each of those, or?
No, great question. So it's absorbance based or volume based, right? So we could use one sample for the top volume. So for 5,000 microliters, it would be one blank vial at that point. If it's below that 5,000 microliters, so let's say we're doing 20 microliters, you could get up to 40 reps. The PCS is monitoring that the whole time, right? So it'll know when it reaches maximum absorbance. So then it'll tell you to switch to blank vials. As you'll see in a second, Megan, I was running some tests with this morning in general. I already have a blank vial in here. It's not going to ask me to change the blank at that point.
Oh,
like Kate said within the chat as well, we recommend, after 30 minutes of opening a blank, using another one at that point. But, the PCS is tracking it the whole time. So it's not one sample per blank or one pipette per blank. You have, maximum absorbance or maximum volume from that.
Okay, thank you.
Rachel, did you have a question too?
Yeah, just I'm looking at the system for a school, so it would be for student use. So I would need a ton of blanks. Would that be a pretty heavy cost, do you think?
Great question. The blanks actually, they look very small, but they have a lot of capabilities. I was doing a demo a couple of weeks ago, and we were looking at around 200 microliters, and we were able to get 20 to 30 reps per almost. The blanks, I'll tell you for reference, in a bulk kit, it comes with 50 blank vials to begin with. Cost-wise, we could actually take a look at what do you think the cadence will be and provide you with it. We have a consumable analysis tool. So let's take that a little offline, Rachel, and let's try to work out the numbers and see what it looks like for you. In general, and you're going to see this a little bit later, I have some numbers in this. They're actually not as expensive as you think they probably are. So hold that, take a look at our numbers later, and then your account manager can work with you to find the best suitable solution that's cost effective as well.
Thank you.
No problem. Other questions from anyone before we roll into the software? Cool. All right. Like I said, I love the questions, so keep them coming, whether it be in the chat or throwing your hand up or just taking yourself off mute. Cool. So give me 1 second. I'm just going to share my screen again. Before we get into me flipping it around and showing you what my PCS looks like, I just kind of want to show you guys a little bit of the software. So great. I'm just going to go to my home screen real quick. Wonderful. So this is our software in a nutshell. This is Artelware. I like to call this Get Started tab within our home screen, kind of like there's a central dogma of molecular biology, right? RNA to DNA to protein. I feel like this is our central dogma when it comes to this software. It guides you sequentially through what to do. So today we're going to walk through these relatively quickly, but it's pretty simplistic. So I'm just going to follow 1 through 6 to show you guys exactly what to do. So adding a user, relatively easy. I'm just going to click this real quickly. You can add as many users as you want to. So you could see we have 1 user in the software right now. If I wanted to add, I don't know, Bob to the software real quick and add Bob's email address, totally easy, totally simple. And then we have different classifications for groups, right? Administrators have the keys to the kingdom. They can really do everything within the software. Liquid handler owners, which basically own the liquid handler, to operators, which could really only do calibrations or trainings, pipette owners, reviewers, and trainers that have different permissions within the software. These permissions are totally editable. You could create other groups if you like them better as well, but premise is pretty simple. Then we could assign Bob a username and then a password as well. Everything with a red asterisk you have to input. Anything without a red asterisk you don't have to input, but will still show up in the reports. So that's as easy as inputting a user. So I'm just going to throw in a quick Bob username real quick. So we'll save Bob in here. And you can see I have the compliance suite that we're talking about earlier. I have it on in my software currently. So that's why it's asking me to have an audit comment. If we didn't have that compliance suite as part of the software, you wouldn't be getting this audit comment at this point as well. Oh, it looks like the password that I created for Bob was not a nice password. It didn't adhere to the Windows requirement, so that's why it's telling me that it rejected it at that point. Great, so now we added Bob. The other thing that you don't see here, we also have Windows authentication. So if you guys wanted Windows authentication, relatively simple to use when we're setting it up, we can enable that portion of the software. So users will log in with their normal credentials like they would log into their laptop or desktop at that point as well. So that's as simple as adding a user. I'm going to go back to the home screen. So pretty much you add 1 user once, they're always there at that point. If you want to retire a user later, you totally can, but you only have to add it once. Same thing for location, pretty simplistic. I'm going to call this Artel West Coast. You can either call it the location that you're at. You can call it specific labs if you want to. Pretty much configurable for what you guys want to at the end of the day. I'll save that in here. Beautiful. We have Artel West Coast. Once again, pretty upfront, right? Once I add the user and add a location, I don't have to do those things again unless I want to add new users or new locations. So it's pretty simplistic. Adding an instrument, you can see these Artelware's integrated, so we have all of our systems on here, right? So you can see we have the PCS, we have the older version of our PCS, that's super old, but then we have this balance connect portion. So as long as your balance has the 6 protocol, it's integratable with the PCS for volumes that are over 5,000 microliters at that point. So I'm not going to add the PCS in here because I already have it in my software. We only have to add it once. If I want to just show you that it lives in the software, you can see the PCS. You can have multiple PCSs that are in the same software, totally feasible as well. If you had the MVS or any other one of our systems, you can integrate those in our software too. Cool. So 1 through 3, that's the pretty upfront work. You only really have to do these things once and probably never do it again, like I said, unless you're adding new users, new location, or new instruments, but it's pretty simplistic. All right, let's get into the meat and potatoes of this. Adding a device, right? So we're going to add a pipette. So pretty simplistic here. We have a catalog, and within this catalog, I would like to say we have 99.9% of pipettes. Now, if you have a really weird one-off pipette from Amazon or you bought it from somewhere, no worries as well. But we have, I would say, most of the pipettes that you could think of in here. So for today's purposes, I have a Rainin. So I'm going to find the Rainin that I have specifically. So it's pretty easy to find. Like you see all these Rainins. All these are filterable to find it. I have a P20 to 200. So I'll look for the min volume. Find that real quick. You see the different versions of our Rainins as well. I'm going to choose this pipette light because that's the model I have as well. So once you hit that model, it's in there, really easy. We also have a pipette ID. That is totally up to you. You can call the pipette ID whatever you want to. If you guys have an asset label that makes sense to you, go for it. All that you need to know is whatever works for you at that point. So I'm just going to choose something really arbitrary for purposes of this for a pipette ID, but you guys could choose whatever you want to. And most customers will use the pipette asset number there. Description, serial number, you could input all of these things that'll show up on the data report for purposes of the day. I won't at this point, but pretty simple. And then we're going to assign it a location and an owner. So I will just assign it to myself at this point. And then I will do that. That's as easy as adding a pipette. If you had a lot of the same pipettes, there's this nice little clone feature. If my Teams will let me hit it right over here. Sorry, let me minimize my Teams real quick. The top bar is interfering with this. So this little clone feature right here, you could clone it all. It's the same pipette type. It'll just have you input a new pipette ID, right? Because it is a new pipette at that point. Great. So we inputted a pipette. Now, next thing that we're going to do is create a plan, right? How are we going to test this pipette? So we have a couple different ways you could do it. So what we didn't talk about a little bit about earlier, we also have operator assessment. So instead of calibration of pipette, I like to call this calibrating an operator, totally integratable as well. But for purposes of this demo, let's hit pipette calibration. We'll do this. So the name, you could call it whatever name you want to. For purposes of the day, I'm just going to call it 200 microliter Rainin. Replicates, make it easy on me today. I'm going to call it 4. And then tolerances, we have a list of different tolerances that you can choose, right? So we have manufacturer specs, ISO specs, and user defined. We don't really, as a company, recommend manufacturer ISO specs. They're very, very, very tight and really, really hard for people to hit. Unless you're really, really good pipetters and are in really controlled environments, they're pretty tough to hit at the end of the day. If you do choose to use these, we also have this multiplier function. So if the spec is relatively tight, you can increase the multiplier a little bit also. For today, I'm just going to use user defined. We actually have a lab report that goes over specific tolerances for different volumes. I believe it's lab report 5 for us with different variable pipettes. So if you need some guidance on this, we have that as well. For today, I'm just going to make it 200 and make my life easy by just hitting 5 for inaccuracy and 5 for imprecision also. If anyone here knows what as found as left is, which I'm sure a lot of you know as well, we also have these capabilities too. So we require as found as left if you want it. We also have the nice feature of skipping an as left calibration if as found passes, and then also specifying a different number of replicates for the as left calibration. So you have that functionality if you want it. If that means something to you, if you don't, and that's all gibberish to you, don't ever worry about that. So I'll hit approve here. And so once again, because I have Audit Trail on currently, I'm going to have to input my e-sig real quick. It'd be nice if I put the correct password here. Oh, so then it approves the report. Once again, if I have a lot of the same things, I could clone these as well. So great. So to go back to the start, we added a device, right? We input our pipette. We inputted ultimately what volumes we wanted to test with pipette. Now we can put this pipette on a schedule, right? So I'm going to do pipette calibration schedule. Once again, we can do this for operator assessment schedule too. So if we want to use this as a means to operator assessment, we could put our operators on a schedule as well, whether that be quarterly, weekly, monthly, yearly, doesn't matter. We have that capability. So pipette calibration, I'll click OK there. Once again, nomenclature is totally up to you. I'll just say demo annually. Cool. Pipette calibration, and we have different types, right? Once again, we can use operator training, external pipette calibration, all these options. I'm just going to say pipette calibration. We could say when it repeats. So I said annually, I'll do it every year, right? And you have that option. You could say every 2 years, months, whatever. Completion date or due date, right? So the due date, we could set those to the end of the month, or completion date is if I did it today, I would have to complete it by next February 28th, 2025 at that point. And then I'm able to add what pipettes and plans I want to add to it, right? So I'm just going to choose this pipette and then this plan that we talked about earlier and set the first due date as today, but you can configure it to set the due date for it whenever you want it to. Put that in there, hit save. Once again, I'll just type in an audit comment. That's it. So ultimately, we walked A through Z of how to add it within the software. So we'll go back to home. And you can now see that we have one pipette due in the software. So what I'm going to do is I'm going to turn my screen around and let's calibrate this pipette now together. So give me 1 second and I will turn my camera over to my integrated, to my GoPro. Give that 1 second and hopefully it connects. Great. Now you guys get to see the PCS in the flesh. Wonderful. All right. So let's walk through this now. So I'm going to click this pipette. And then I'm going to do start calibration. And once again, I'm going to choose my PCS at this point. So it takes a second to connect. Great. Cool. So basically, all we're going to do now is follow this banner. This banner kind of tells us exactly what to do, when to do it. So you're going to see this red light on the actual PCS. That is an integrated barcode scanner. All of our consumables actually have a nice little barcode on them. So essentially what I'm going to do, what you guys are going to see, it's probably a little bit harder to see because you're looking at a bird's eye view. I'm just going to scan this QualAssure bottle too. So in order to do that, let me get up real quick to scan it. Boom. So that scanned it. So basically what it's doing is checking to make sure the temperature is in a range. It vortexes a couple times to do that as well. And then I already have a blank within this. So normally what you would do is actually scan your blank, put it in. I already did this earlier to save us a little bit of time here, but essentially all I'm going to do now is pipette my 200 microliters into that blank vial. When I do that, you're going to see that label there. I'm going to pipette it below the label and normally onto the side of the glass. If you pipette it above the label, that vortex mixer is pretty strong, so it might skip out the solution. Why I say onto the side of the glass and not specifically touching the diluent or that blue solution is measured relatively well, and that if you aspirate up any of it, it'll ultimately affect the calculation. Right, so let me move this over here. You guys can see as well, I only have a multi-channel at home, so I'm going to only put one tip on one of my channels here to make my life a little bit easier. And I already have this dial I have it dialed to 200 microliters, and I already have some of my QualAssure 1 aliquoted out right here. So essentially what I'm going to do is I'll pre-wet a couple times. I already pre-wetted a little bit earlier, but let's do this again. Right, and then I am going to dispense it into my file. Cool. Now along the PCS, and it might be harder for you guys to see it, it's a capacitive touch sensor. It kind of looks like a dolphin smile. If I touch anywhere with surface tension area, it'll close it. So I'm going to do that now. Essentially what it's going to do, it'll vortex mix 3 times and then give us our first reading. So you basically get one data point in the span of less than 10 seconds. I'm going to do that again. So you can see now we have the first volume. It's a little bit over, which is fine. This pipette hasn't been calibrated in a little bit a while, so the accuracy is relatively good at 200. And now you can see the replicate 1 and replicate 2. So you have the in precision and then accuracy as well. Great. That's the last replicate. Wonderful. So you can see all of the replicates are in there. Other things that we can add, let's say one of the replicates was off. You can see the first one was a little low. I probably didn't pre-wet well enough at this point, but let's say I wanted to redo replicate, I totally can. It's just going to ask me for a valid excuse as to why I'm going to be redoing the replicate. It will show that within my data report. If I want to record the environment as well and put that, the pipette tip information, add a comment, you can add all of these functionalities and it will show up in the report at that point. But for now, I'm going to hit finish. I'm going to sign once again, because my compliance suite is on, I'm going to sign this. And then I have to send it to a reviewer because I have that reviewer format on. So I can choose what reviewer I want to. There's not many in the software. I'm just going to choose to send it to myself at this point. And then I'm going to send it. Great. Wonderful. And now you can see what one of our data reports looks like. So it's pretty nice. It has all of the information that we inputted earlier. It has the specific calibration ID as well. You can see all of our tolerances and all of the statistics that we have, all of the replicates, any of the lot information, expiration for any of our consumables, and ultimately who did it at this point, right? And now you can see, because it's in the review process, it says pending for approval. So let me X out of this real quick. Go back to the home screen. I am logged in as an admin. Let me log into my other account, who I sent it to as the reviewer, and then let's just show you guys real quick. I'm going to log in real quick. I know it stopped sharing my screen, but I'll log in and re-share my screen in a second. Share my screen again. Okay. So I logged into the reviewer as Nick now, and you can see it ready for review. I'll just click that. And then I could view the report. And then you can see this at the very top right corner, I have this little green check mark or this X. So I have the ability to either approve it or reject it. I'm going to approve this report. Once again, it's going to make me put in my e-signature. And now that report's approved. So at the bottom, it went from pending to approved and who reviewed it in their e-signature as well. These reports can be exported as a PDF, Word, or Excel file. If you want to even set up a printer to print out the reports, that can be easily connected to the PCS. Great. That's all I had for that portion. I have a few more slides, and then we should get you on out of here or have some questions at that point. Cool. Let me just flip my camera back to me real quick, and then I will get back to sharing my screen. Great. All right. Can everyone see my screen again, the presentation?
Yes, sir.
Beautiful. Thank you so much, Nate. Cool. So we kind of went through the PCS. We went through A through C, but how does this ultimately help your labs? Because that's why we're all here today, right? So I wanted to ask some questions that probably a little bit of why you guys are thinking about potentially utilizing the PCS, but what happens when one of your pipettes doesn't perform, right? Is there currently a way to check it that you have? And what happens if you don't think it performs? Do you take it out of use and wait till the next calibration cycle to send them out? And then also, how can you really ensure that all your pipettes and operators are consistently performing across multiple labs and multiple sites? That standardization is something we as a company see all the time, and the lack of standardization, and ultimately a lot of errors and a lot of troubleshooting because of that. And then what happens if you get audited and they inquire about your pipettes and one of them is out of spec, right? It's funny, I'll give you guys a quick little story about that. I was at a demo a few weeks ago with now it's going to be one of our customers, but they got audited. The auditor found that their pipette was out of spec, and they've been working on rework for that pipette's implication on all their testing for the past few months now. And the auditor basically said, off record that the PCS is ultimately the way to go to help allay a lot of their fears and concerns moving forward. Now, sources of variability, right, when it comes to pipetting. A lot of it is operator technique. So we've classified all these into kind of a pie chart as well, right? You have predictable failure, environmental conditions, innate variability, accidental failure, and operator technique. The PCS can take a lot of that variability out of it, right? Standardizing your operators, ensuring that you're not having accidental failure. If accidents happen. I was a scientist once in a lab. I drop pipettes all the time. I'm clumsy, right? So, and we could pretty much help mitigate a lot of these things. And then secondly, right, cost of repeats. So these are just a few different assay workflows and kind of how much per capita each one costs and the cost burden. But imagine, and I'm sure this may have happened and hopefully it doesn't happen in the future, you find a few pipettes are out of spec. And now you're looking through all the data that for one of these assays that you've done for the last few months. And now there's a cost burden associated with it. Not just the cost of rework, but the cost that you actually have for those specific samples and those specific assays. So these assays, as you know, science is not cheap at the end of the day, right? So this means it could be a great deal to the bottom line of any organization or business. Now, and we know there's other methods out there, right? There's gravimetry, which some of you may use now. There's external calibration, where you send those pipettes out for calibration. And then there's ratiometric photometry. We think when it comes to the comparison between all of them, ratiometric photometry really, really comes out ahead. So, you can see that ratiometric photometry is just a lot more accurate and precise than gravimetry. It's portable, right? Balances don't like to be moved. There's not method variability, which even external calibration companies have, and we really don't have environmental susceptibility for any of what we have for our PCS. And then lastly, right, cost. And this I know is a big thing to everyone. We're in an economic environment now where everyone's worried about the bottom line. So these are classic customer examples. I promise you I'm not pulling the wool over on anyone's eyes over here. These are actually numbers that we did with a couple people that came over from external calibration and customers that came over from gravimetry. So in this first example, you can see this company was paying around $27,000 a year for external calibration services. We did the consumable analysis and realized that it would only cost them around $5,000 a year by going with the PCS. So you can see that basically they paid off the PCS in less than a year at that point. Now, this might not be everyone's example with exorbitant of an external calibration cost, but $5,000 for PCS calibration is relatively cheap compared to other methods. So even from a cost per data point, the external calibration company was charging around $3.40, whereas the PCS came in around 68 cents. Even with gravimetry, right? So gravimetry, we really worry about time and data collection. That process takes a very, very long time. So we made the assumption that the normal FTE time with overheads around $75 to $100. So we compared that with this customer, their external calibration versus gravimetry versus the PCS. And the PCS was miles ahead of gravimetry and miles ahead of external calibration. We did this method for our multi-channel, our MDS as well, but you can see that from a cost perspective, the PCS really, really shines when it comes to external calibration and gravimetry as well.